Hello everyone, now I'm going to show you how I use the RC522 RFID module which scans cards and user tags. So this is the RFID RC522 module, and this module uses 7 pins which are SDA, SCK, MISO, MOSI, IRQ, GND, 3.3 volts and RST. In this video we will not be using IRQ because it is not required, and we will be using the other 6 pins, and we'll also be using a buzzer for this activity. For the SDA, I have connected it to pin number 10, the SCK to pin number 13, and the MISO to pin number 11, and the MISO to pin number 12, the RST to pin number 9, and the 3.3V pin to the 3.3V pin on the Arduino, and the GND to the GND pin on the Arduino. For the buzzer, I have connected the plus side to pin number 8, and the black wire to pin number to the pin GND. Later on, I'll explain the code for this activity, and right now, if you want, I can show you how it works. So right now, this is a user tag, and there is also a card, which is just this blank card. And using this card, if you tap on this, it should make the noise of a buzzer. So if I try the card, so later on I'll explain the code, and you can later on keep adding more upgrades to this by adding conditionals to show if access is allowed or not. Hello everyone, now this is the code for my RFID RC522 module, and this is the two libraries required, which is spi.h and mfrc522.h. So spi.h is just an inbuilt library, and mfrc522.h is a library which you should install from here. So if I go to install, you can see the mfrc522 library is already installed in my computer, and you should install it in yours. So in the setup, I have written serial.begin, the usual for printing the in the serial monitor, and in the spi.begin to begin the to start the SPI reading, and my RFID dot PCD underscore init is the initialization of the RFID module at ss underscore pin and rst underscore pin right here. SS underscore pin is nothing but the SDA pin, which is connected at pin number 10, and RST pin is connected at pin number 9. So this is the buzzer pin, which will make the buzzer noise. In pin mode, buzzer is output, and a function called no tone for buzzer is written here so that the buzzer doesn't make any noise. And in serial.println, I'll start with this line. If you want, you can put this, or if you don't want, you can just remove it. In the void loop, if not my RFID dot PICC underscore new card present, return nothing. So it just returns nothing. If there is no card, if a new card is not present, it will just return nothing. If not even new card serial is present, if not even a read card serial, then it will return nothing. If a card is found, it will go to serial.println card detected, and it will print the serial.print UID, which is the user ID of the card, and Here I have created a variable called I, which is a data type byte, and if it is lesser than my rfid.uid.size, it should be I should always be lesser than my rfid.uid.size. If it reaches the size of the rfid, it will stop incrementing. So in serial.print my rfid dot uid byte of I will be printed along with the hex value of the card. And in serial dot, and again in serial dot print, it will leave a space. This is just for the next line. And again tone buzzer comma 1000 will keep the buzzer at this noise level, which is 1000. And no, and after 0.3 seconds, the buzzer will become to no tone. My rfid.picc underscore halt a will just halt the scanning, and my rfid.pcd underscore stop crypto 1 will just stop the reading of the will just stop reading the hex value of the card. And again after some time it will start that, which is 1 second. So later on I will show you how to connect the LCD to the RFID to print values in the LCD. Thank you.